Well, the focus today is exponential equations. And I want to start today by saying, look, what makes this an exponential equation? It's the fact that the exponent is a variable. So what is the answer for that first question? Pop it in the chat. And let me know what is the answer to that first exponential equation. I see Nicole was off to a good start there. Who else feels like they know what's going on? The lady agrees with Nicole. Then who else? Tinswallow. Okay, perfect. I think you guys have all realized that if you make 8 2 to the power of 3, then you can clearly see that x must be equal to 3. Okay, so that's a simple exponential equation where we make sure the bases are the same to allow us to find the answer. All good. Let's go to a question like this, which is a little bit harder. I want to know from students in the room what makes this question, this exponential equation, quite a bit harder than the last one. So you can put your hand up if you want to give an audio comment, because I know it's a bit quicker, or what else can you do? And welcome to Ashia Ndeen and Appreciate, who has just joined us. So Nicole has said we don't have the same bases. I agree with you, Nicole. Does anybody have an idea of what the base we would like it to be is? Or what a first step may be? What would your first step be? So Naledi has given a very nice tip. Naledi has said, look, I know that 125 can actually be broken down to be a power of 5 as well. And Naledi, I completely agree with you. I also think that since we are comparing exponential equations, often it's good to have like a situation like this, where we have something on this side and something on that side. So before we use Naledi's tip, what else could we do to help us get going? Before we use Naledi's tip, what else could we do to get going? It's a nice one, Naledi. I like it. Okay, so transpose this exactly. So if you move this to the other side, you are going to get that it becomes positive 125 to the power of 2x minus 3. Okay, now, that is good news because we can use Naledi's tip to take that. And I want you to tell me, what is 125 as a power of 5? What should that be? We know that this is still going to be 2x minus 3. We also know that this part is going to be like that. But what I want to know is what needs to go here. Okay, let's have a look at the chat here. What is going on in the chat? Buchler has said power of 3. Nicole agrees. I agree. Okay. I want you to try and solve this exponential equation from this point. So we've done step 1, what was to move across. Step 2 was to break into prime factors. And then I want you to try and solve it from here. I'm going to give you a minute to try and do it, and then we're going to go from there. Let's see if we can do it. Welcome to Manila. Who else has joined us? Nico, Olale. Welcome aboard, everyone. Din and Taka Kenny. Yeah, welcome. Okay, so we're working on this problem, and we're trying to see what is. Now, I want to say take out insurance. And what I mean by take out insurance is put a bracket around this power. This 3 needs to be applied to everything here. And when you've got an answer for this, tell me done in the chat. So the way you let me know whether you had enough time is you just say done in the chat. Then I know you're done with this question. Okay, so the very difficult step was getting this bit right. But if you got that bit right, oh, let me go backwards there. If you got that bit right, oh, let me go forward. Then it should be a case of now saying, look, the bases are the same. So therefore, 2x plus 1 equals 6x minus 9. And then if I bring the 9 across, I get 1 plus 9 equals 6x minus 2x. And then I'm going to have 10 equals 4x. And then I'm going to divide both sides by 4. And then x should be 10 over 4 or 2.5. Now, that was a bit quick, but give me a thumbs up if you followed my thinking there. Give me a thumbs down, or either you can do happy face, unhappy face, or thumbs up, thumbs down. Or if you're in the middle, you can go meh face. But I want to know how you're feeling, because remember, I can't see your faces. If I was in class, I could read your body language. But obviously, because I'm not looking at you on the camera, I need to feel what you're feeling. And so this helps me. I see the reactions coming through, so that's awesome. Thanks, everyone. So let's go on to a second question. Okay, now, these are a nice collection of exponential. Let me actually just move things down so it's a bit less cluttered. I do like to keep my screen. I do like to zoom in a lot because I know that you guys are on cell phones, and a lot of you, and so it's easier when it's bigger. Okay, I want you to do number 1 for me. So number 1, can you do number 1? And for those who are really feeling on fire, you can do number 4. So see if you can solve those 2 exponential equations. Awesome. Gemma says, life is good. Lanico, Tinswalo, Ukle. Okay. Indian, also. So don't be afraid to let me know how you're feeling, guys. It is nice to. Okay. Let's give it a go. Now, if I was looking for tips, I would definitely look at breaking the 9 and the 27 down somehow. That would be my tip. Number 1. So I think now we have to be very careful because that 9 is here. And then the x plus 3 is actually sitting in its own bracket, which is properly sneaky. And then this is a 3 to the 1. And on this side, I have 3 to the 3. And then that 2x minus 1 is in its own little bracket. So I'm going to give you that as some help for number 1, because actually number 1 is a bit trickier than I first thought. And I'm also open, if you raise your hand and you want to ask a question, that's also a quick way to get your point across. So see if you... So if I avoid the minefield, then I should get to that point. Give me a thumbs up if you follow me up to that step. Okay. All right. So those who are comfortable, you can move on to number 4. I'm going to finish off the other one in a moment. I just want to give a little bit more time. And then let us go to, let's have a look. Where does this go from here? Okay. So we have 3. So 1 plus 6 is 7. So 2x plus 7. And this is 3 to the 6x minus 3. And now we're going to say, look, if the bases are the same, then these must be equal. So I'm actually just going to go up here and I'm going to go 2x plus 7 is equal to 6x minus 3. I get 7 plus 3 is 6x minus 2x. Oh my gosh, is this the same answer? 10 equals, so 10 equals 4x. 10 over 4 is x. And did everyone else get 2.5? Again. Oh my goodness. Okay, let's see if we can do number 4. What is going to be the key step for number 4? I feel like the 100 has to be broken down into 10 squared. And then from there, can you get the answer? And just say done when you're done with that one. All right. So if I multiply this by this, I get x squared plus x equals 10 squared. Ooh, I'm having flashbacks to class here because now I know that the 10s are equal, which means I have x squared plus x equals 2. But then, oh my goodness, what is this type of equation called? Appreciate, I will absolutely, I can write a bit clearer. Yeah. If that is, let me actually zoom in so you can really see what I'm doing and also try and write a bit neater if I can. Yeah, I'll do my best. Okay. So what type of equation is this? It's a trinomial. Yeah. Pilar, you are absolutely correct. And how do we solve trinomials? Well, it depends on what you've learned. You can either use the quadratic formula or you can factorize it in whatever method you like. But we know that we're going to have an x and an x, yeah, open two brackets, and then the factors are going to be 2 and 1, and I'm going to have a plus and a minus. So then what are my answers going to be? X is equal to what? X is equal to what? So the only way that this equation could be true is if x was minus 2. Actually, let's split them. Like what we normally do with a quadratic is we say, look, the one part must be 0 or the other part must be 0, in which case x must be minus 2. X must be minus 2 or x must be 1. So that was a little bit tougher because it was an exponential one with a quadratic inside, but it tested a few basics. So again, give me a class vote. Thumbs up if you feel okay. Thumbs down if you feel a bit lost. Let's just see how everyone is feeling in class now. Okay, so I pushed you there, hey? That wasn't an easy question. So take a screenshot now if you need to of the working out, and then I'm going to move on to the next question. But you're doing well. I like what I'm seeing. Like what I'm seeing. Okay, then let's move on. So, well, let's do this one actually. Number 2. There's one key step with exponential equations, and this trick happens a lot. What's the problem with number 2? There's something that's making it very difficult. I'd love someone to put their hand up and tell me, or to let me know in the chats. There's one key bit of insight that you have to see to help you solve this exponential equation. What do you think it is? Yes, you guys are on this. 1 can be written as 3 to the 0. And boy, is that helpful, because now I can say that that is true. And that's brilliant news because both the bases are the same. So therefore, we know 2x minus 12 equals 0. Find me the value of x and put it in the chat. Find me the value of x and put it in the chat. Find me the value of x and put it in the chat. What do we think the value of x is going to be? I think we bring the 12 across, and then we divide it by 2, and we get the answer x is 6. Tender, got it. Appreciate, got it. You are brilliant. Okay, you know what? You've outgrown this type of question, so it's time to move to a different type of question, and that is equations with rational exponents. And I'm just going to do one of these before we have our break today. And so let's have a look at how this feels different. Okay, look at this type of equation. Here, this is an equation, but the exponent is not x. The exponent is a rational number or a fraction. And so in order to solve this, this can be a little bit tricky. And so you know what we're going to do is we're going to work on a new method. What we really want to do is we want to get this x to the power of a half to become x, to become an x, but we can't do that. And so we want it to become x to the 1. We can't do that unless we do the same thing to the both sides. So we want to find a way to turn this into x to the 1. So we need to find a way to undo this to the power of a half. So who has some ideas of how we can undo the power of a half, or get x to the power of a half to x to the power of 1, and then we have to do the same thing to this side so that we don't break the equation? Okay, Nicole, you're very close. Appreciate this. So what we raising both sides to the power of a half, which is a little bit different. Okay. So what we say is sorry, not to the power of a half, we raise it to the power of 2. Now, what does it mean if we raise something to the power of 2? We are squaring it. And remember from the last lesson that a power of a half is the same as a square root. So it makes sense that a squaring something would undo square rooting. So let's see how this works. We go 2 times a half. What's 2 times a half? I'll put it over 1. It's just going to be 1. What is 3 squared? It's just going to be 9. And so x is 9 is our answer. So will that work? Well, put in your calculator 9 to the power of a half. I'll wait. What do you get if you put in your calculator 9 to the power of a half? What do you get if you put in your calculator 9 to the power of a half? Yeah, you get 3, because what you know is 9 to the power of a half is actually the same as the square root. And so that makes sense that it would be 3. And so we know it's a solution. Okay, so that's an example. Let's have a look at, let's have a look. 2, 4, 3. 3. Let's have a look. 3 over 2. Okay, let's have a look at number 3 before we have a break. Okay. I want you to try and solve, we just solved another type of exponential equation. And in this question, x is to the power of 3 over 4. I want you to think, and let me leave the last question up on the board so you can see it to help you. I want you to think, what do you need to do to solve question 3? And maybe people in the class can even help us. We know that we need to do something that is somewhat like this. So it's got something to do with this, but we probably don't raise it to the power of 2. But we do know we want to end up with x to the power of 1. And so I'm going to ask the class as a group, can you help each other? What do you think we should do? What do you think we should do? Okay, so appreciate you 95% correct. It's not that you divide both sides by 4 over 3, but rather you raise both sides to the power of 4 over 3. So appreciate has said, if we raise this side to the power of 4 over 3, okay, so let's do that. Now, if we leave it like that, we've broken it. It's no longer equal to 8. But if I do this, well, then we're on to something, aren't we? So now I want you to try and solve, get me an answer for x using what you know about exponential. Like, you can break the 8 down And I also want to see what else you can figure out. See if you can figure out with X, and then it's break time. Okay. I like what we're seeing here. So we have, if I multiply this by this and this by this, I get x to the 1. And on this side, I have 8, but I'm going to write it like this. So now, what is that going to do? Well, I think I can cancel out that. And I get x is 2 to the 4. And then 2 times 2 is 4 times 2 is 8. And I get 16. Okay, so there we go. So what we have is we have a new type of equation, okay, that we need to be able to deal with. And we're going to continue with that after the break. But for now, I think you've done really well. So just give me an indication, thumbs up if you're feeling good, thumbs down if you're feeling unsure. And so I can see kind of what is going on with the students of my room. Okay, then we've reached the most important part of the day, everyone. It is time for a brain break. And if you've been here before, you know that means we do some aerobics. So I want you to turn your cameras on. I want to see your happy faces, and you can join me in some fantastic body maintenance. And we are just going to start by just stretching up because it's been a long day and our bodies need to be taken care of. And we're going to stretch to the left, stretch to the right. We're going to shake our arms. And you may think, oh, this man is being so silly, but I promise you this resets my concentration as much as it resets yours. Shake out your legs, get some blood flow going. And then let's just start with some basic rotating. So a gentle rotation, nothing crazy. And then as we relax, we start to feel our body twist further. Okay. And then let's do a little tricep stretch. So you'll feel triceps and also your stomach. And let's do another one. Okay, and then last thing, get the blood pumping. This is really what resets your brain. We're going to do jumping jacks, and we're going to do 15. And I want to see everyone doing this. So don't be shy. Make sure you don't have any vases nearby, and let's get stuck in. Okay, 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so our express aerobics session is over. I do hope you can let me know in the chat how you're feeling. I do feel slightly out of breath, as I'm sure you do too. But I promise you it will help us be better at learning. And, that's one of the main reasons that we are here. Okay, see if you can solve the puzzle. How much is a triangle worth? Can you solve the riddle? That is your puzzle for today. So let's start with circles. How much is the circle going to be worth? How much is the circle going to be worth? I think that Naledi is on it. So Naledi, you are right. This is going to be 5. It's the only way that this thing can work. And now we need to decide what the square is. Now, 5 times something square, I see it in the chat. The square is going to be a 2. So what is the triangle have to be? 5 times 2 is 10. And then what is the triangle going to be to make this whole thing work? What is the triangle going to be to make this whole thing work? Who knows their BODMAS? 5 times 2 is 10. And then there's something times 5, and then it equals 5. I think the only way that this could be true is if there was a 1 there, because 1 times 5 is 5, and 10 minus 5 would be 5. And so the triangle has to be 1. Okay, and I see Dean agrees with me. All right, so did you enjoy the brain break today? Do you feel ready for a second part of class? Do you feel somewhat restored? How are you doing out there? Okay. So let's do this. So here are some tips that you can keep in mind when you are doing these equations where the powers are fractions. When working with equations, you must do the same operation to both sides of the equation. So if you square one side, you must square the other. Then the other thing is, get the variable with the fraction exponent on one side by itself. Sometimes we say isolate. Then the next step is get x itself by changing the fraction exponent to an exponent of 1. So that's what we were doing up above when we were saying raising it to the power of 4 over 3 on both sides. We were trying to get it so that x to the power of 1 was by itself. And then it says do this, last bit, do this by choosing an exponent for both sides so that xmn becomes x to the 1. That's basically what we were doing. Okay, so let's keep practicing. So let's try and do this one, because this is a little bit more tasty, and we have to use something that we learned earlier in the week. So some of you may say, hold on, mister, you have not taught us this stuff before, but maybe somebody who was in class can help me change this from what's called root form into power form. So the goal is to solve for x, but in order to solve for x, I need to deal with this rather nasty looking radical sign. And maybe someone in class can give us a tip, a top tip to help us. What have we got in the chat here? Someone has, okay, now let's have a look. What's in the chat? Nicole has said 4 to the power of x4. Okay. Nicole is referring to the law that says, if you've got that, you can also rewrite it like that. So you can bring the thing that is here to be over there. And so we can rewrite this as x to the power of 4 over 5 equals 256. Okay, I like it. And then it says, Appreciate has said, can we change 256 to 16? We could, but I think the main problem now at the moment is this 4 over 5. And I want you guys to design a procedure that you do to both sides, that when you do it, you make the x a 1. So that's the goal. And I want you to think about what you need to do to make the x a 1. Okay, 256 to 2 to the power of 8. You can do that, absolutely. Let's have a look. So you can either write 256. In fact, there's probably 2 of them. If you hit the fact button on your calculator, I suspect you can get 2 to the 8, or you could also get 4 to the power of 4. 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the power of 4. 4 to the power of 4 is 4 to the po So 2 to the 8, or you could get 4 to the power of 4. Both of those are helpful, and we'll get to them in a moment. But what's the main thing? I think the main thing we need to do is raise both sides to the power of 5 over 4. Give me a thumbs up if you understand why I'm choosing 5 over 4 and not some other random number. I want to see how many people that's bringing happiness to and how many people it's bringing confusion to. Like, why is this guy choosing 5 over 4? Let me see the emoticons fly. I want to see what the people of my class think about this one. Okay. Now, and don't be shy. Remember, that's the nice thing about these classes. There's a certain amount of, like, we get to know each other, but there's also anonymity. So you really can express how you're feeling about the question. Okay. Now, if I caught you out, the reason I caught you out is because you haven't realized that whenever I raise it to the power, I always use the reciprocal of what was there. So reciprocal is a fancy word for saying, look, I flip it upside down. So at the moment, it's 4 over 5. Then I raise it to 5 over 4. I just flip these numbers around. But if I do it to the one side, I must also do it to that side. So as it stands now, I've got x to the 1, but now I've got another problem. I've got to figure out what this means if I'm not allowed to use my calculator. And this is where I can make a choice. I can either make this, I can use my calculator and get 2 to the 8. And in fact, actually, that's probably the easiest way to do it. So if I do that, what is my final answer for x going to be? Without using the calculator, you need to get me an actual value here, or as close to it as you can. So it's 8 over 1. So I think I go 8 times 5 is 40. And then 1 times, it's 4. So the final answer is 2 to the power of 10. And if you write 2 to the power of 10, you're going to get 1024, I think. But it's 2 times 2 times 2, 10 times. And just to make sure we've done this right, we're going to check. So I want you to take the answer, 1024, and you're going to put it where the x is. And then you're going to say 1024 to the power of 4 over 5. And tell me what you get. What do you get when you go 1024 to the power of 4 over 5? And hopefully we can get the same answer that I'm kind of holding thumbs that it's 256. This is good news for both you and me. We're on the right track. We're on the road to freedom. Okay, everyone, you are doing very well. So let's try and do number 3. Now, this is a little bit different, but I have faith that you're going to figure out what's going on here. Do your best work here. Find me the value of x here. Find me the value of x. Okay. What do we have here? Who can give us a hint for the first step? I feel like Gemma is just waiting to help us. Laniko, let's ask Laniko, what should we do? What do you think would be a good first step?
The first step, we should remove the number in front of the Yes, the 3. So we're gonna divide what we do on the right, on the left hand side, also do on the right, and then it's gonna give
Perfect.
us 1x alone. So it's gonna give us 1x to the third, and then it's equals to x to the power of, it's equals to 4. So we're
You
gonna take
perfect. And now what do you do after that?
and then we're gonna take we're gonna put on the brackets, and then we do the reciprocals, and then we're gonna be put 3 over over 1. What we do on also do on the other side. So
Perfect.
after that, we're gonna put on our calculator, or we're gonna say that 2 is to the power of 2, and then we're gonna do our reciprocals again.
So
So it's gonna
just to jump in, you're absolutely right. So I just want to draw attention here. So what Lonico is saying is, look, I looked at 1/3, and what's the reciprocal? Let me actually, I was going a bit fast. 3/1 is the reciprocal, and if I do that, I get x to the 1. Lonico, I was thinking, if we end up with 4 to the power of 3, yeah, because the 12, and let me get rid of this because this is a bit confusing. This is all the way up here. This is going to be 4 to the power of 3. We can actually just go 4 times 4 times 4. Would you agree?
yes, sir. It's gonna give us 64.
Perfect. Yeah. 64 is going to be the answer. Thank you, Lanika. That was super helpful. You've obviously been practicing your exponents. You know them
Yes,
well.
yes, sir.
Okay, let's try one more. Let's see. Can you... Let's see how much time we got left. Okay, let's see if we can squeeze in these two. I want you to try and do these two for me to finish today. And then I think we are pretty much done for today. I think we don't want to overfill your brains. So see if you can solve 2.1 and 2.3 for me. Okay. And when you're done with it, you can just put your answer in the chat so that we can see what you guys get. But I want to give you time to do it. I don't want to rush you. Okay, Nomfundo, Naledi has answers coming through in the chat. I'll see if I agree in a moment. I just need to do it myself. Buchle also, and you're all getting the same answer, so I'm guessing that looks good. So I think that we are going to raise this to 3/2 and 3/2. And then we're going to get x to the 1. But I'm going to rewrite my 4 as 2 squared. And then the 3/2 is out there. And now the 2's cancel. And I get left with x is 2 to the 3, or x is 8. And that is looking very, very good, ladies and gentlemen. Okay, one more, and then we are finished for tonight. Now, the problem is this is a fraction. Might need to go to the team for a tip. How do we deal with fractions, bearing in mind that we kind of know what we need to do to solve this? We need to have bases that are the same. Who has some ideas that can share with our friends in class here? I think the key is to recognize that 125 is 5 to the power of 3. So that's the equivalent. But now I'm still a bit stuck. I need to do one more thing to get my answer. And that one thing I need to do is I need to go back to lesson 1 and remember I can bring this above the line. And then I will get 5 to the x equals 5 to the minus 3. And then x is minus 3. All right. That was a very nice lesson.